Okay, hello. This is Energy System Technology, Lab 7, which is understanding electrical schematics. I will go over the lab right now, and I will do this recording to help you watch it if you missed the lab or if you need some kind of reminder when you did the lab. So the purpose of this lab is to understand electrical schematics, and one way to understand schematics is to draw them and know how to trace the lines between components of a small board or a small appliance. And I have an aquastat here. Usually the aquastat comes in a box, so I took it out of the box, and this is what we see over here. I took it apart so you can look at it a little bit. So if you look at this board here, this little combination of components, let's start with the lab. So you will get one of those aquastats, and you'll pry it open from this box. Probably need some pliers and a screwdriver. So I have it already in here. So for the first part, we did take it apart. There are two types of, actually there's many types of aquastat. This is an old-fashioned one with all the wires in the back, so you can see the connection between the terminals. These are still in business, they're still working. And this is one with a printed board, and they get more advanced with more solid state relays. So we took out the aquastat here, and once you have the board by itself, try to look at the terminals. So I'm trying to analyze what am I looking at here. So in the assignment, I'm asking you to draw a schematic using a blank sheet. So if I were to write this schematics, I will start with a square just to represent what's happening in here. And I will look at the components, and luckily these boards are labeled, so you can see the labels here: L1, L2, T and T, ZR and ZC, and a switch here. So the first thing I will do is I will label those terminals. I have L1 and L2, which is here, and we know L1 is hot and L2 is neutral. And I will label this terminal as TT, and TT is thermostat. And I will check the video and see, yeah, it's clear. I'm gonna go a little bit further, and so you can see it more. Thermostat. So if I look at this component here, it is a transformer. A transformer changes power either up or down. In this case, it is down because I have line voltage, which is 120 volts, and my thermostat, usually all thermostat, or most of them, are 24 volts. So I will put the symbol of a transformer here. You can find that in the book, just to make sure that I'm doing it in the right location. And this here is a relay. If you can look at it, the relay has a coil and has two contacts. So I will draw the contacts the way they are, which is basically two contacts, and I will put in this relay here as my coil here, the way it is. So whenever this line energizes, it will power the coil, and it will pull in this contacts together in here. So I got that, and in here I have two switches, so I can symbolize that by just two switches. These are the high and low limits, and they are operating mechanically to turn on or off something in this board, and we can follow through using this. So if you look in here, you have two switches, and those switches connected from the black and white wire. So I will go and put blue here, the wire, and this is black. Okay, so look at that. Switches, blue and black, and coming out of those switches are two lines. One of them is yellow, and the other one is red. And now that's the hard part, actually, which is not that bad. So if I look closely and I follow and trace those connections here, it doesn't seem that difficult to connect. So I will go and see that line 1 here connects all the way to, from the shade here, there's a connection here. They connect all the way to S2 here, which goes to part of the coil. So I have line 1 going from a node here to some part of the coil, and the other part here is going to neutral. So this will connect. I'll do a jump here, and this will connect to the neutral. Okay, so we get some part of the coil, and if I notice the other part of this coil, which is here and here, you'll see that this coil is powering one of the thermostat and part of this coil here, if you just follow the connection over here by looking at it. And the other side here of the thermostat connects, I'm going to jump over here, all the way to the coil. So we can see that the thermostat is a switch that will complete the circuit for the coil. The line voltage will come to the transformer. The transformer will have 24 volts, and this here will complete the switch. A thermostat is basically a switch that will turn on by heat. Okay, so that's some first part. Then I will go into these contacts here. So I have 2 contacts that I already drew out here, and one of them has the red wire coming to it. So I'm gonna go and put the red wire over here, and the other one has, if I look here, it has the C1 terminal connected to it, and that's C1, and next to it I'll put C2, and I'm adding this whatever I see in here, and I got B1 and B2, and I have a ZR and ZC. So if I keep the connection, I'm looking at a white wire coming all the way to ZC. I'll connect that the way it is to here. And for the C1, it's already been connected to one of the coil. And what about the black wire? The black wire, if I trace that, is going back all the way along with the blue and the black. They connect together into, if I look here, into one part of this other end of the coil. So these both will connect to here. They connect to the other part of that relay. So once this relay is energized, it will close, and this line voltage will go through and power our red line. So the red line will come out, and the yellow line will go all the way, the yellow here will go all the way to the B1, which B1 goes to the boiler. And if I follow the other lines, B2 and C2 over here, they connect with each other. So a jump and a dot means connection. So they're connected to each other, and they're going all the way to the neutral line, which is over there. So I'm going to do another jump here, another jump here, and I'll do a connection in here. It's starting to look a little bit messy, but you know where does it go from here. So we got that. What about the Z? We got the ZC. What about the ZR? ZR is coming all the way from with these 2 connections. So another connection will come from here and here all the way to ZR, which is here. Okay, the ZR and ZC are for the additional zone. Okay, so this shouldn't take that long, or take your time doing it. And the second part is comparing your schematic to the manufacturer's schematic. And if you look at it, it looks a lot the same, and just a little bit, just compare what you did and how it did come out to be. And then I'm asking you to use a multimeter to test the continuity for this aquastat. So a good way to do that, to know if this aquastat is working or not, is to test for continuity. Let me just check the here, continuity, check the video is going. Okay, the video is going. So I got my continuity going. Where is it? There you go. Okay, I have my continuity, and I'll go and check after completing part 1. We can compare the schematic, and using multimeter and continuity setting, test continuity between the connections. So I'm going to test between all these connections. If I go from here to here, it should be. If I test the continuity for this coil, it should be. In theory, it should. It did. I have to get that, so it's working. I can check the continuity in here, and by checking continuity, you know that this coil is working and we have solid connection. And then you can measure the resistance of the transformer primary and secondary winding. So I'll put that in resistance, and I'll check the transformer's primary winding, which is here. I expect the primary to be much higher than what am I doing? Okay. If I check this, I'm gonna get 100 ohms. You can see that. If I go to the secondary part over here, this should be less than that. It's very small. You can't. No way. Come on. It can't be this small. Or could be, because we are changing to 24. It's very small. It's not even measuring it. Okay. I get 6 ohms. So between 100 and 6, that makes a little bit sense for the winding to change from high to down. Measure the resistance of the transformer secondary and primary. Use continuity test the relay for function. So how do we test those relay? We do test the coil continuity, and you can test those little connections in here and see if they are continuous or not. If I put 2 leads in those settings and I press with my finger here, these should connect. You can have a colleague help you do that to test that this contact actually are making the proper connection. And that's about it to answer the questions. So what is the line voltage coming into the board? We know line voltage is 110. Hot is L1, neutral is L2. What is the secondary voltage of the transformer? Secondary is what's coming out, and here we got 24 coming out. What is the resistance of the primary winding in the transformer? We got 100 ohms. What type of switches are there in the board? So let's think about that. On the board we have 2 high limit switches, and the thermostat can be considered a switch, but it's outside, it's not the board. So we have 2 high and low limit switches. What does TT stand for? Well, that's what you see in here, and TT is thermostat. Using the schematic in part 2, connect to the following. If you look at these connection here, you can see that B1 and B2 connects to the burner control, and C1 and C2 connects to the circulator. ZR and ZC are connection to an additional zone. So you can see, and you can notice that one of them is neutral, one of them is hot, and one of them is neutral. So B2 is neutral, C2 is neutral, and this is zone neutral. And probably the ZC stands for Z common, probably, and ZR is probably Z red, or the line voltage coming to it. Okay, how do you test the relay for the relay contacts? You basically do continuity and try to have this contact connected. This is very useful to do it in these types of aquastat, but in other ones it's a little bit more tricky because they are solid state. Would reversing L1 and L2 affect the control function, and why? Thinking about that, I think it will pretty much affect the function, because that will reverse the entire operation of this aquastat, and that's a common mistake that happens when wiring an aquastat. Okay, so we'll do this for this week, and if you can rewind and look at the controls again if you have any questions. Thank you.